In this segment of geometry, we're going to be talking specifically about triangles. Now, in an earlier segment, we talked about the angular relationships of triangles, and we pointed out the fact that every triangle, regardless of the type of triangle or its size, the angles will always add up to be 180 degrees. Now, in addition to the angular information, we want to take a look at some of the rules regarding the sides of triangles. So let's get started. Okay, let's take a look at this board together. You'll notice that I have drawn 3 different triangles up here. They're each different in certain ways. I've used the letter S here to show that on each of these triangles that there are certain relationships with regard to the sides. In this first one, these 2 sides are equal. Now, anytime you have a triangle where 2 sides are equal, it's called an isosceles triangle. Now, why do you need to know that? Well, that may be only one of the only pieces of information they give you in a question. They'll say, we have an isosceles triangle. And if you don't know that means you have 2 sides equal, you might not know how to approach the problem. So remember that an isosceles triangle has 2 equal sides. This second triangle here is a right triangle, and they'll usually put a little rectangle there to show you that it's a 90-degree angle there. And 2 of the sides are equal, so this is what they call an isosceles right triangle. Now, the thing you need to know about an isosceles right triangle is the relationship between the 2 angles that are not the 90-degree angle. Both of them are equal, and both of them are 45 degrees. In some problems, this will be important information that you need to know. As a matter of fact, we'll look at the little cheat sheet that they have inside each of the math sections on the SAT and show you how that information can be used. Let's look at this last triangle down here. It's an equilateral triangle, and I've dropped a perpendicular from the vertex down to the bottom of it, the opposite side, and it becomes it separates it into 2 90-degree right triangles. Now, they're not isosceles right triangles. You can tell that by looking at them, but they are right triangles. Now, why do I want to show you this information? Well, the reason is, let's first back up and look at the whole triangle as a whole. Any equilateral triangle, each of these angles are going to be 60 degrees. This one over here is 60 degrees, and this one over here is 60 degrees. Now, that's the whole angle, that's 60 degrees. But when you drop a perpendicular and you have it separated into 2 right triangles, the important thing is I want to show you is this little angle here and this little angle over here, each of those are 30 degrees, which makes sense because they have to add up to the 60 degrees. Again, there are some important relationships you have to know about a 30, 60, 90-degree triangle, just like you need to know the relationships that happen in a 45, 45, 90-degree triangle. Okay, so those are the 3 types of triangles and the angular relationships that I want you to understand. Now I want you to look at something that's called the Pythagorean triplet. Now, all of you know the Pythagorean theorem, and the Pythagorean theorem says that this is the hypotenuse, that the square of the hypotenuse equals the sum of the squares of the other 2 sides. And you have probably done those problems to the point where you never want to see another one of them. You know what you have to do when you're doing those. You have to take the square root of both sides to find a solution. You have to be careful that if they give you one of the sides and they want you to find the hypotenuse or the other side or whatever, you've got to make sure you watch your signs when you're going from one side to the other. But we won't do any of those problems right now, because what I want to show you here with regard to the Pythagorean triplet is that the Pythagorean triplets are all what they call similar triangles. Now, what's that mean? That means if they are Pythagorean triplets, all the angles are equal in those triangles, okay? Now, let's say that this one here is a 3, 4, 5. That's called a triplet, and you just have to remember that. The ratio of the sides, 3, 4, 5. And that's your first Pythagorean triplet. Let's say this one over here, it's probably, let's say 7, 12, 13. Now, you don't have to remember all the Pythagorean triplets, but you probably should remember these two, because they are often used on the exam. But don't panic. If you do forget what the Pythagorean triplets are, invariably every problem that involves a triplet could also be done with the Pythagorean theorem, except that if you know the triplets, oftentimes you can cut the problem-solving time in half. Okay, so those are the triplets, 3, 4, 5, and 7, 12, 13. Let's now take a look at similar triangles. I told you that the triplets are always similar triangles, but these aren't triplets here, and they happen to be similar triangles. So if a problem tells you they're similar triangles, and they want to know a relationship, all you have to remember is that you have to match up the ratios with the proper sides. For instance, I can say 8:16 as long as I do it in the same order, 3:6. And if you did a cross multiplication, you would see this equals 48, that equals 48. And if you were solving for x, okay, you would want to maybe say that x is to 3 as y is to 6. And maybe you did another calculation somewhere where you found y, and then you could figure out what x is. So you'll be working with similar triangles. So that is basically what you need to know about triangles. And now what we're going to do is look at some specific problems where we use this information. Okay, here we have a typical easy triangle problem. In this one, they give you the triangle ABC, and they show you a 90-degree angle here and show this side of this little right triangle as being 1. Now, a lot of times you're going to see extraneous information inside these problems to try to catch the Joe Boggs. Now, Joe Boggs may think, oh, wow, I've got to deal with right triangle here, and maybe this is a right triangle, I add them all up together. No. It's nothing that's that complicated here. They say if AC equals 4, that's this whole line segment here, what is the area of ABC? Okay? Remember that you have a cheat sheet in every math section of the SAT, and you can turn to it at any time. And it has all the formulas for area, circumference, the things that you're going to need to know, the formulas are there. So what we would do is we'd take a look at that cheat sheet. Let's pretend I turned back in the book there, or maybe I was on the same page where it is. And I look and see, okay, what's the area for a triangle? It's the area equals 1/2 the base times the height, okay? That seems simple enough. So the area equals 1/2 the base times the height. This is our base, it's 4. So let's just write these things in. Equals 1/2 times 4. And they gave us the height of this triangle too. It's 1. And so 1/2 times 4 times 1 will equal 2. And of course, that's your answer.